This segment on deduplication is going to provide a general overview of how deduplication works. In general, what we're looking at here is the data is going to be read into a memory buffer. Now, the data is going to be read from the source. We are going to compress it. By default, compression is on. You could always turn that off. But we compress the data and we put it into the buffer. Once that buffer hits 128K, which is default, we know that's configurable. It could go from 32K up to 512K. That's in the UI. It actually could be configured additionally in different ways, but that is not part of the UI. Once we hit that buffer, we're going to generate a signature on that block. Signature gets checked in the deduplication database. Here we're going to do check in the dedup signature. We're going to look to see if it's unique. If it's unique, we're going to send the block over to the disk library, and then we are going to register that signature in the dedup database. Very important to note, and this is something that we cover in a future video, that signature is being registered in a database, but it doesn't immediately get committed. We'll talk more about the commit process and chunk updates when we get into data protection concepts with these deduplication videos. If the signature is duplicate, we're going to toss out the block. We're going to increase the counter in the dedup database, and any metadata associated, we will send it over. Now, about this memory buffer and what we're doing here, the default 128K, we have to realize, and take file system as an example. Not every file is evenly divisible by 128K. So what we might end up having is either a trailing segment of that file that we're reading or an entire file that's below 128K. And this is something that we refer to as content-aware deduplication. So if we have that trailing segment or a file smaller than 120K, and by the way, just to let you know, that minimum fallback size, that's what we call it. Minimum fallback size, any content that's below 128K all the way down to 4K, which is the minimum fallback size, we put into the buffer, and then we pad the buffer. That is to say, we don't take additional data from, let's say, the next file and put it into that buffer. We generate the signature with just that data there, check it in, either discard it or send it on its way. Content-aware deduplication is a really important concept because what this means is if you have file data that has been backed up and it never changes, that file will always fold into itself. One of the questions come up, and some of our competitors will talk about the small block size, 816K, variable shift, and all of those things, that they get better deduplication ratios. I'm not going to say that is or is not the case. It really depends on what type of data it is and what type of Commvault agent you're using. That more applies to database agents than file system agents, which we can have a separate conversation about that. But the idea of the content aware means we could use a larger block size and still get the comparable and sometimes better deduplication ratios. Most importantly is we are putting this data in 128K pieces into the library. This means a couple of things. Number one, deduplication will always lead to data fragmentation. There's no way you can get around it. That's the nature of deduplication. But our fragmentation in Commvault deduplication is less because we're using a bigger block size. Again, because of content-aware deduplication, it's not that big of a deal. We still get good dedupe ratios. But the second thing is because of the larger block size, there's less signatures or metadata that is being used to manage where all those blocks exist. Therefore, Commvault deduplication can scale higher. You throw partition deduplication into that, it's even better. The added benefit, what most people will not see until they go to do the restore, is because of the larger block size, the less fragmentation on disk, the faster your restores are going to be. So you put all this stuff together, provides a good overview of deduplication, gives you a little bit of extra insight into how this process works. And we will be using some of these concepts to expand on this as we get into additional videos.